Okay, so if all integers are divisible by 1, and then for 2's, if it ends in an even number, so 0, 2, 4, 6, or 8, then 2 is a factor of it. And then if the sum of the digits of a number is a multiple of 3, then 3 is a factor of it. And then if the last two digits are a multiple of 4, then 4 is a factor of it. So let's take, for example, 136, right? So 1 is definitely a factor of it. And then 2 is also a factor of it because it ends in 2. However, 6 plus 3 plus 1 is 10, which isn't a factor, which isn't a multiple of 3. So 3 is not a factor of it. And then 4, since 36 is divisible by 4, the last two digits are a multiple of 4. So 4 is a factor. So yeah. Okay. And then for 5, 6, 8, 9, and 10, and then we will go over 7. So is 5 a factor of it? If it ends in 0 or 5, then yes. And then for 6, if it follows the rules for both a multiple of 2 and 3, then yes. So if it ends in an even number and the sum of the digits are a multiple of 3, then then 6 is its factor. And then for 8, if the last three digits are a multiple of 8, so for example, 102, or wait, no. For example, 280, right? That is, if those are the last three digits, then that number is a multiple of 8. And then 9, if the sum of the digits are a multiple of 9, then it is a multiple of 9. And then if it ends in 0, 10 is its factor. Now, 7 is special. So it has a more complex rule. So if you multiply the units digit by 2 and find the difference between the remaining part of the number and what you found in the previous part, and repeat that until you get a 1-digit integer, then if the integer is 7 or 0, you'll have a multiple of 7. So take like 1,257, for example, or 52, sorry. So you'd multiply the units digit by 2, so you would get 4. Right? And then you'd find the difference between 125 and 4. So 125 minus 4 is 121, right? So now you would take that units digit of 1 and you would multiply that by 2. So 12 minus 2 is equal to 10, right? So now you take the units digit, which is 0, multiply that by 2, which is also 0, and then subtract that from 1, and you would get 1. So 1,252 is not a multiple of 7. Okay. Also like asking questions. But okay, so some practice problems. Is 12,805 divisible by 7 in the chat? Answer.
Wait, can you show me how to do it again?
Oh, yeah. Do you want me to do the example or just show you the slide?
Can you do another example?
Okay. Okay. So I will take another number, 4,762. Okay. So we take 2 because that's the units digit, and we'd multiply it by 2, right? So we would get 4. And then the rest of the number is 476. So what we would do is we'd subtract 4 from 476, and we'd get 472, right? So now that we have 472, we'd repeat the steps again. So we'd multiply the units digit by 2, and we would get 4, and then subtract that from 47. So 47 minus 4 is 43, right? And then we'd multiply this units digit by 2, so 3 times 2 is 6. So then when we subtract 6 from 4, we get -2. -2 or 2 is not 0 or 7, so therefore it is not a multiple. 7 is not a factor.
Okay, so this is to find out if an integer is a multiple of 7.
Yeah.
And this works for any number, or is it just for 7?
This only works for 7.
Okay.
Yeah. So yeah. Also, you all might be thinking like, if I could just divide it by 7, then like, what's the point of knowing this? It can be helpful in cases where like the numbers are variables. So then you'd actually, where some of the numbers are variables, you'd be able to use that rule rather than kind of like having to just like go through trial and error for the variables. So yeah. So in the chat, is 12,805 divisible by 10? And again, if you do not understand, ask questions, because that will help you understand. Or just say in the chat, like, I don't get it. You can private message me, if you have questions or feel, or like, don't understand what. Okay, so I see 3 answers. So, what we would do is we would take the units digit, in this case, multiply it by 2, so we get 10, right? So 1280 minus 10 is 1270. And then now we take the units digit and multiply by 2 and subtract that from 127. So 127 minus 0 is 127, right? Now we take the units digit, which is 7, multiplied by 2, we get 14. We subtract 14 from 12, and we get that it is -2, which is not 0 or 7. So therefore, this is not divisible by 7. So you all are correct. Is 113128 divisible by 8 in the chat? And if you want me to go back or re-explain anything.
Yeah, can you go back again? I forgot what you do if it's not 7.
Okay, yeah. So for 8, what you would do is take the last 3 numbers of it and take that number, whatever it is. And if that's a multiple of 8, then 8 is a factor. Okay, so I am seeing a couple different answers. So the answer is yes. So what we would do is we would take the last 3 numbers, which is 128, right? And we'd see if that's divisible by 8. So 128 divided by 8, we should be able to calculate as equal to 16, right? So when we divide it, so that means that 128 is a multiple of 8. So that means that this number is divisible by 8. Okay, is 1278 divisible by 9? Okay, so I am seeing a couple different answers. So what we would do is we would add the numbers together, the digits together, and see if that is a multiple of 9. If it is, then this number is divisible by 9. So 1 plus 2 plus 7 plus 8 is equal to 18. 18 is divisible by 9, so therefore this number is divisible by 9. Is 8935 divisible by 3?
What's the rule for 3 again?
For 3, it's if the digits sum to a multiple of 3. So it's like 9, but not.
Wouldn't long division just usually be faster, or?
For some of these, it just depends on like the size of the number. Like for example, if it were like a 2 or 3 digit number, then, well, okay, I think for me personally, like for the 3 and the 9, like for some of these rules, it's just always faster for me to use the divisibility rule. Like, for example, 8, you just look at the last 3 digits, right? But it can be, if like whatever works for you, you know,
But like, let's say if you're trying to figure out if it's divisible by 3 and it's like a 25 digit long number.
I mean, I feel like it would take either a similar amount of time or less if you're just adding, right?
True.
So, yeah. Okay, so I'm seeing some answers in the chat. So 8, so we would just add 8, 9, 3, and 5 and see if that is a multiple or if that is divisible by 3. It adds up to 25, which is not divisible by 3, so this number is not divisible by 3. Okay, is 129,484 divisible by 6? So remember, 6 is where it follows the rules for both 2 and for 3. If it's divisible by that. Okay, so I am seeing some answers in the chat. So we can tell that it follows the rule for 2, right? It ends in an even number. So for 3, now what we have to do is we have to see if the digits sum to a multiple of 3. So 1 plus 2 plus 9 plus 4 plus 8 plus 4 is equal to 28, which is not divisible by 3. So therefore, this is not divisible by 6. So you all are correct. Okay, is 28,784 divisible by 7? So again, it's like special, like the rule. You take the units digit, multiply by 2, subtract, and just repeat. Okay, so yeah, some of you have answered, so it is yes. So we would take, okay, wait, let me, okay. So we take the units digit, which is 4, and multiply by 2, and we get 8. So 2878 minus 8 is 2870. So now we take the units digit of that, multiply by 2, subtract it from the rest, and we get 287. And then we take the units digit, which is 7, multiply by 2, we get 14, subtract that from 28, and we get 14. And then 14, we take the units digit, which is 4, multiply by 2, subtract from 1, we get -7. And since -7 is a multiple of, it's like, since -7 is -7, it is divisible by 7. So yes, you all are correct. Okay. So another thing to remember, if you are trying to see if x, so any number x, is a multiple of a composite number y, then first what you have to do is you have to find the prime factorization of y. And then if x is divisible by all the prime factors of y, then x is divisible by y. So for example, if we're trying to see if a number is divisible by 15, right, we would have to make sure that it's divisible, that it follows the divisibility rules for both 3 and for 5. Also another thing to note is that if y is divisible by like a number squared, like in the prime factorization, for example, 5 squared, you need to make sure that the number you're trying to see that is divisible by y is also divisible by this number and not just 5. So for example, if we were trying to see if 65 is divisible by 25, we know 65 is divisible by 5, which is technically all of the prime factors of 25, but that doesn't mean 65 is divisible by 25. So you need to make sure it's divisible by 5 squared, not just 5. So yeah. So some harder practice problems. So this
Wait, can you go back? Can I look at the slide a bit again?
Oh yeah, sorry.
Okay, I'm good.
Okay. Okay, so this is some harder practice. So this is actually an AMC problem. So, you know, it just gives you some like, not perspective, but like, it's like how it could be applied. So how many four-digit positive integers, so between 1,000 and 9,999 inclusive, having only even digits are divisible by 5? So in the chat, put your answer. I'd prefer if you private message me your answer for this one. Also, if you do have any questions or just don't know how to solve it, just private message me, like, hey, I don't know what to do, or something along those lines, or just ask any questions. And I will give you all until so 5 minutes until 7:32.
Wait, what question was this again? You said it was like state or something?
I said it was AMC.
Oh.
So yeah, I will tell you like which AMC it is after. So, yeah.
Wait, AMC is multiple choice?
Yes, it does. For the AMC 8, you have 5 answers, and same for the AMC 10 and 12. But basically, if you get a question wrong, you get 0 points. If you get it correct, you get 5 points, I think, or but you aren't penalized for guessing a wrong answer on the AMC uh 8. However, you are for the AMC 10 and 12. So yeah, that's the only real difference. Okay, so I have gotten three different responses. So actually okay, so I don't think you all read the question correctly. So remember it says only even digits and divisible by 5, right? So if it's divisible by 5 and it only has even digits, that means the last digit would have to be 0, right? So there's one choice for that. And then we know we're gonna have three other digits because this is a 4-digit positive integer, right? So for the first digit, the leftmost digit, we can have either 2, 4, 6, or 8 as the numbers, because if it starts with a 0, then it's not between 1,000 and 9,999. So we have 4 options for that, right? And then for the second from the left, that digit, we can have 0, 2, 4, 6, or 8. And then same with the third digit, because we can have 0, 2, 4, 6, or 8, right? So that means what we have to do is 4 times 5 times 5 times 1, which is equal to 100. Yeah. I think a lot of you didn't read. You probably, well, I don't know what y'all did, but I think some of you didn't think that the last digit had to be even also, so you thought it could be 0 or 5, and you got
Oh, I
two.
forgot the second digit had to be even too.
Oh, yeah, that could mess up your answer. Yeah. But yeah, it is 100. I don't know if any of you got that. However, like, don't feel bad. This is like an AMC 10 problem. So you all still have a few years to go
Oh, I
until
forgot the formula.
yeah, but like you all do know how to solve this. You just messed up right now. So, if you were actually taking the test, you'd probably get this, which is like good because it is AMC 10. Okay. This one's an AMC 8 problem. So the digits 1, 2, 3, 4, and 5 are each used once to write a five-digit number PQRST. The 3-digit number PQR is divisible by 4. The 3-digit number QRS is divisible by 5, and the 3-digit number RST is divisible by 3. What is P? So I will give you 5 minutes for this. So 7:30.
So in this case, P would be the tens of thousands place, and then Q would be okay.
Yeah, it would.
And in PQR, P would be the hundredths place.
Yeah. So PQR, P would be hundreds, Q would be tens, R would be ones, and then QRS, that's different. So Q would be hundreds, R would be tens, S would be ones. So yeah, and same with RST, R is hundreds, S is tens, T is ones. So yeah. Okay, so I'll give you all like an extra minute to finish solving, because only a few of you have answered, so I'll give you all until like 7:41-ish. Okay, it is 7:41. So, okay. So the digits 1, 2, 3, 4, and 5 are each used once to write out this 5-digit number. So we know the 3-digit number PQR is divisible by 4, and the 3-digit number QRS is divisible by 5, right? And the 3-digit number RST is divisible by 3. So what is P? So we know QRS has to end in 5, right? Because our divisibility rules for 5 say that it has to end in 0 or 5, but since 5 is the only option here, we know S is 5, right? So we know that we know that it's like this, right? So we have this number. Okay, no, I'm not sorry. Yeah, this is our number, right? So we know it's divisible by 5. So we know that that is 5, right? And then we know the 3-digit number PQR is divisible by 4. So that means that QR can either be 12, 32, or 24, right? And the reason for this is because we know in order to be divisible by 4, the last 2 digits have to be divisible by 4. And the only way for this to be is if it's 12, 32, or 24. Technically, it could be 54, but since we already used the 5, there's only the 5 can't be used, right? So next we know RST is divisible by 3. So let's test each of these out, right? So the 2 and the 4 for R, since that would mean, since this R is equal to this R, right? So let's test out the 2 and the 4 to see which ones work, right? So we know that the S is 5, right? So if the R were 2, and the S were 5, which we know it has to be, then that means T has to be 2 or 5, which is impossible because we've already used those numbers once. The reason T has to be 2 or 5 is because the sum of the digits in RST must be equal to a multiple of 3, and 2 plus 5 is 7. So to add to that, we can have 2 added to it to get 9, or 5 added to it to get 12. So both are impossible. So that means 12 and 32 cannot work for PQR since R cannot be 2. So that must mean that PQR ends in 24, right? So 2 and 4 are Q and R. So we know that R is 4, so S is 5. So T must be 3, because 4 plus 5 is 9, and to get a multiple of 3 as the sum, we need to add a multiple of 3. And the only way to do that is to get 3 here. So that means that P is the last digit to be used, or 1 is the last digit to be used. And that also has to be P, right? Because P is that first digit, that 10,000th digit. So that means that the answer is A. Do you all need me to re-explain that or anything? Because I know a lot of you did not answer. In the chat, like private message me any questions, or if you want me to re-explain.
I just randomly guessed.
Shri guessed. Shri, was it at least an educated guess? Like, did you have some facts? Like, did you know it was,
Yes.
like, for example, 1, 2, or 3?
Yeah. No, I was
Okay.
actually educated because like what I did was it's divided by 4, so 4 is not available. And then it's divided by 5, so 5 is not available. And then it's divided by 3, so 3 is not available. So it's either 2 or 1.
Oh, I see.
That,
And
I mean, at
it
least
was
you got it.
50-50.
Yeah. You know, if you get it on the actual test, it doesn't matter how you got to it, as long as you get it. So, you know,
So
That's-
basically it's 50-50.
Yeah. Yeah, educated guesses are also a good strategy on the AMC. Okay, yeah, so this just explains that. Okay, so another thing we're going to be going over is prime factorization. And then if we have time, we'll do Kahoots. I do not think we're going to have time, but okay, let's get into it. So what is a prime number? So a prime number is any number that has only two factors, so exactly two factors, one and itself. So 17 is a prime number because it has 17 and 1 as its only factors. However, 15 is not because 15, 5, 3, and 1 are its factors, and that's more than 2. And something to note is that 1 is not a prime factor or prime number since it only has one factor. So in the chat, is 91 a prime number?
Wait, oh my God, I wasn't paying attention. Can you go back to the previous slide? Sorry.
Okay. Yeah. So yeah.
Oh, okay, never mind. So is there like a specific, is there any specific formula to solve it?
No, but you can use your divisibility rules potentially.
Oh, I guess. Like,
Yeah. Or you could just try like whichever numbers seem like they could potentially divide it, just try to divide by them.
okay.
Okay, so you all are mostly correct. So it is not a prime number because it is divisible by 7 and 13. So, you could use your divisibility rule, multiply the units digit by 2 and get 9 minus 2, which is 7, or you could just no, it's a multiple of 7 and 13. It is not divisible by 9. You might have misread the number, but it is not. Is 103 a prime number in the chat?
So there's no like surefire way to there's no actually sure formula to solve if it's a prime number.
Right. You'd kind of have to go to every factor that is less than the square root of the number, or less than or equal to the square root. Because yeah. Okay, so yeah, you all are right. It is not a prime number. Since it's only divisible, or it is a prime number, sorry, because it's only divisible by 1 in itself. So yeah. Okay, so basically the only number that's the odd numbers between 100 and 110, the only one that isn't a prime number is 105. Yeah, I see you all were quick to correct yourself right after I said, yeah, okay. Is 82 a prime number? Yeah, you all are correct this time. It ends in an even number. We know that means it's divisible by 2. So it is not a prime number. So, okay. Now, what is prime factorization? It's where you find the prime factors that multiply to become a number. So since each prime number only has a factor of itself in 1, each prime factorization is unique to a number. So let's try to find the prime factorization of 2021. So, okay, yeah.
You mean 2022?
What? sorry.
You said find the prime factorization of 2021.
Oh, yeah, 2022. Yeah, I meant 2022. Yeah, sorry, I still read it as 2021. Yeah, no, okay. So the prime factorization of 2022. So what we would do is we would divide by the primes that we know that we can automatically see it is divisible by, right? So 2022, we can see that the numbers add up to 6, right? And that is divisible by 3. So we know it's automatically a multiple of 3. So we divide that by 3. And then we see 674, which is what's remaining, is divisible by 2. So we divide it by 2. And then we see the remaining is 337, which is a prime. So we got it, its prime factorization is 2 times 3 times 337. So in the chat, what is the prime factorization of 2700? So in this case, it would be easiest to first divide by the smallest primes and then go up, because that will help you be organized. Yeah. Also, the prime factorization for 2700 is a bit big because it is divisible by a lot of numbers a lot of times. Like, yeah. Okay, so yeah, a lot of you, a couple of you have answered in the chat. So the prime factorization is 2 squared times 3 cubed times 5 squared. A lot of you wrote it out, which is cool, but also remember, use your exponents because it makes it a lot easier to read. So I think you did all get it correct though. But yeah, so you would divide by the smallest first, so 2 squared. So 2700, you can tell it's divisible by 2, and you do that twice and you get 675. You can tell it's divisible by 5, so you divide, or 5 squared, so you divide by that, and then you get 3 cubed as the remaining part left over. So yeah. Okay, so what do you all want to do? More prime factorizations, or what do you want to do a Kahoot? Out of curiosity.
Kahoot.
Okay. Yeah, I assumed so. So would you all rather do a divisibility rules one or prime factorization? Or does it not matter to you at all? Okay, I will just select one. Okay. So yeah. Okay, so like 1 second. It is being slow, but give it a second. Okay. Okay. Would you all rather have okay. Okay. Would you all rather have the like new modes or would you rather have the classic mode? Like the
The
new mode.
classic.
Okay. Do you all agree with that or just the new modes are these? Okay. I shall assume. Okay. Yeah. Okay. So the code is 4347656. I put the link in the chat. Yeah. I will assume the rest of you will join during the Kahoot. Yeah. Okay, question 1. Which of the following is 5205 divisible by? I think that's all here. Okay. Yeah, you all did get it. Some of you got it. It's 3 and 5. You should have noticed it's divisible by 5, and the only one, 3, 4, and 5, it can't be divisible by 4 since it doesn't end in an even number. So yeah, so it should have been. Yep. Okay. 405 is divisible by okay, it's 3 and 9. So you should have added up the digits 4 and 5, seen it adds up to 9, which is a multiple of 3 and a multiple of 9. It's not divisible by 3 and 6 because it doesn't end in an even number. Yeah. 508 is divisible by okay, yeah, it's 2 and 4. Yeah, you all got that. No need for explaining. Yeah. 348 is divisible by which of the following? Okay, so it's 2, 3, and 4. Some of you just said 2. Remember, 48, it's divisible by 4, so it should be divisible by 4. And the only one that includes that is 2, 3, and 4. So, yeah. Or actually, no, all of you got that. 5912 is divisible by 6. True or false? Okay, yeah, it is false. It's not divisible by 6 because it's not divisible by 3. 5 plus 9 plus 1 plus 2 is not it is 17, which isn't divisible by 3. Okay. 722 is divisible by which of the following? Okay, yeah, it is 2. It's not 2 and 3. 7 plus 2 plus 2 is 11, not a multiple of 3. Okay. 4, 6, 2, 4 is divisible by 4. True or false?
No, I think I got that wrong. No, no, no.
Okay, yeah, no, it is true. It is divisible by 4 because 24 is divisible by 4. Yeah. Okay. Yeah. 5, 9, 1, 2. I think this number was said earlier. Is divisible by. Okay, yeah, it is 4. The last 2 digits are 12, so that is divisible by 4. 1, 2, 1, 2 is divisible by. Okay, yeah, it is green. 1, 2, 1, 2 is divisible by 2 and 4, obviously. We add up the numbers, we see that they add up to 6, so it's divisible by 3. And since it's divisible by 2 and 3, it must be divisible by 6. And 1 plus 2 plus 1 plus 2 is 6, which is not a multiple of 9, so it is not divisible by 9. Is 252 divisible by 9? So yeah, 2 plus 5 plus 2 is 9, which is a multiple of 9. Okay, 381, this is last problem, is divisible by which of the following? Okay, yeah, it is 3. It's not even, so it can't be divisible by any of the other options. So yeah, it is green. So the podium. Good job to Monraj, Colin, and Shrey. Good job. Okay, yeah. Thank you for coming. It is okay, yeah. Okay.